Hello. Today we're going to be talking about 10 different types of data that data scientists use. I'm going to start off with cross-sectional data. Cross-sectional data, it's collected at a single point in time across multiple entities. It helps compare different groups at once. So for example, a business use case would be segmenting customers based on demographics. So you could see here that we segment them based on their annual income and a spending score. We see like young high spender, middle moderate, affluent high spender, young moderate, and so forth. So this is helpful in the sense that we could target specific marketing strategies towards different types of people. Second off, there's something called panel data, and this is observations over time for the same entities. So you capture both cross-sectional and temporal trends, which is just a fancy word for a time series. Okay. A business use case would be measuring customer retention or churn over multiple periods of time. And we could see in this example that we've got people with monthly spend, they're most of zero, they're likely going to churn, right? One. Okay, so that's a quick example. Moving on to our third example, there's time series data. Now, what is it? It's sequential data indexed over time, okay? It's useful for trend analysis and forecasting daily sales or quarterly sales or detecting anomalies and things like server logs. When we look at this example, we could see this nice trending graph. And it's very much a snapshot of business performance. Okay, so it's very useful in that sense. Moving on to the fourth is text data. So what is it? It's unstructured written data like reviews, social posts, or emails, and it captures user feedback and intent. The business use case would be to perform sentiment analysis to improve customer satisfaction. So if we see this list basically containing like a bunch of words. I love this, bad service, and amazing product. We could put it in a word cloud, and this will give us some type of sentiment as to like how the product is being perceived by customers. And of course, you know, if you go into a product in Amazon, you see multiple reviews, and we'd have to aggregate it and count how many times it's positive versus negative and whatnot. Moving on to our fifth data set, there's something called graph network data, and that it's data that maps entities and their relationships. So basically, they're nodes and edges, and the models influence and structure in complex systems. Business use cases are it could detect financial fraud, build recommendation systems, using social or purchase graphs, or I mean, there's social graphs as well, right? Like Facebook and whatnot. In this example, I've got a Les Miserables graph, which is a Broadway musical. And you can see all the characters, basically. The little circles are the nodes, and the lines are called the edges. Now, we could see that if a node connecting a node, right, with an edge, say Mile Babos with this Mile Gil Numrand, we could say that it's kind of in the same scene or same chapter. Okay, so this is how the graph is basically designed. Another one, Muriel and the Count, they appear together in a similar scene. Another word for this is a co-occurrence graph. So there are nodes that are occurring together simultaneously in a specific time frame, if you will. Now, moving on to the sixth is audio data. Audio data is sound data, waveforms, or spectrograms. Why it's useful? It enables voice recognition and acoustic analysis. Like a business use case would be transcribing and analyzing customer service calls or create voice assistants. Now, I give an example using this package called Librosa, and basically it's a trumpet. Now, a trumpet basically as you can tell, there's amplitudes in terms of like how the person blows into the trumpet, right? So if they're blowing hard, it's going to be a lot more volatility, okay? And they're going to be clustering. And then when it kind of when the trumpet is when the trumpeter or the band player basically stops playing, it'll level off. Okay, it'll just stop. There will be no sounding. The seventh is image data. Wait, so I'm sorry, going back here also, I mean, like in terms of customer phone calls as well, I just want to give this example because I think it's important. With customer service calls, you could see that like if it's higher amplitude, maybe the data scientist could read that they're getting more emotional, right? If their voice is getting loud, and that could indicate being upset. Okay, so there's some inference that you could derive from customer service calls as well. So finally, moving on to image data, which is the seventh. What is it? It's data in visual format, pixels and channels. Why it's useful: enables computer vision applications. It detects products, defects, or an assembly line on an assembly line using image classification. Here, it's not a product, I mean, but it's a digit, right? Can we recognize what the digit is? So that's the usefulness of it. Moving on to number 8, geospatial data. It's data tied to physical locations, right? GPS coordinates, latitude, longitude. Why it's useful: it supports spatial decision making. Business use cases: optimize logistic routes or analyze store locations by population density. I give a world map. I mean, people that are interested in, like, say, global sales, this could be a good template to start mapping where their sales are occurring. If it's a multinational organization, global corporation, or whatnot. Moving on to the ninth is video data, and it's basically sequence of images, frames with temporal dynamics. So basically a time series, and it's useful for behavior recognition and motion detection. We could use it in store foot traffic or customer segmentation, customer engagement using surveillance footage. So we look at this data set here. I mean, I pick up every 10th frame. And you could see that we could see this lady basically on the beach. Um, if you look at it, this from this scene to this scene, we could see that her hair is being blown by the wind. Okay. And then moving on to our final type of data set, it's multimodal data. And this is data that has image and text. Okay, so it has multiple modalities for richer representation. It improves, why it's useful: improves model context and interpretability. Okay. Um, the business use case would be power e-commerce search by combining product images and text descriptions. So I personally have worked with image and text data as well, and it's better for classification. If you can't recognize the image per se perfectly or classify the image the way in these machine learning models, you could use the text as kind of like a backup, okay, to kind of accurately classify a image. In this example, I use a dining room table, and here we've got the label, okay, which could be a caption as well, like say in a product catalog, and then I've got the image. And then we use something called pill here, okay? So that wraps it up. Thank you very much, and I'll see you in the next one.